will be a Starfreelancer. Learn new skills. Set your goals. Increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
Welcome back. In this lecture, we are going to understand about Ingress SSL redirect. So which is nothing but in general, whenever we are building our applications and then deploying in production, we usually have a requirement like our HTTP URL should be auto redirected to HTTPS. So most generalized requirement, and then in most of the load balancers we usually do this. Okay, so this became a load balancer setting wherein if you want to redirect your URL from HTTP to HTTPS, you can do it. So how we are going to do that in Ingress manifest, means like Ingress Kubernetes manifest, how we are going to write it. So we are going to look into. So before going there, so we also need to understand something about custom action annotations in Ingress specifically. So let's go back to our GitHub repo and then we'll go to 0805 ALB Ingress SSL redirect, right? So inside this, we need to go to this respective link, okay? So which is nothing but a reference for custom actions, okay? So I'll open it here. So in the annotation section, right? So the first annotation is nothing but the actions.custom action name. So the first annotation, whatever you are seeing, ALB ingress kubernetes.io actions.custom action name, whatever you can provide here. So inside that, if you see it in a very detailed manner, so it provides a method for configuring custom actions on a listener, such as for redirect actions. So that is one important thing. And the second is the action name in the annotation must match the service name in Ingress rules, and service port must be use annotation. Okay, so this one will come to next, but first let's see the first point here, which is provides a method for configuring custom actions on a listener. Let's go back to our load balancer. So we have created this load balancer as part of the previous section, which is nothing but 0804 ALB Ingress SSL. And in this section, we really didn't clean up at the end. So we wantedly didn't clean up anything here. So we'll again come back to 0805 Ingress SSL redirect. And let's try to understand more about what is this provides the method for configuring custom actions on a listener, right? So what are those actions from load balancer's perspective? First see that and then go back and then write it in the Kubernetes Ingress manifest. Okay. So if you see here port 80R443, if you click on view edit rules, so there are a lot of rules you are writing it here. Okay. So when the path is /app/star, so then go to this respective target group. In the same way, if you take it here, so go to this respective target group is the action. So if you want, you can insert a rule here saying that, so when the path is /star, right? And now this is the action, this is the custom action, whatever we are discussing, right? So when this is the case, when it is /star, then redirect to so and so, redirect to HTTPS, or redirect to where he want to redirect to a different protocol, redirect to HTTP another URL, or redirect to HTTPS with a 301 permanently redirected. Okay, so with original host path query. So this is the default rule whatever is present here. Okay, so and the port whatever you want to give 443, and if you say add, so you get this value, right, which is nothing but HTTPS hash host path and then query whatever is provided with a status code HTTP 301. Exactly whatever we have done here on the AWS management console, we are going to write the same thing in the Kubernetes Ingress manifest. That's all. And this path whatever you have written /star is going to be the first one in the port 80 rules. Okay, so all these things will be ignored as soon as we write this, because anything with /star automatically it need to redirect to HTTPS : whatever the host came in from the browser, and the path whatever came from the browser, and if any query tags also append all those things. So like this. So if once we add this and then save it, automatically all these things will become invalidated. So now currently we are not doing it via UI, and we are going to do it via Kubernetes manifest. So we are going to update our Ingress manifest with these details and then apply it, and then see that these changes takes place automatically here. So everything we are going to update in our manifest and then do it. Okay, so now let's go back here, right? So we'll go back, and then in addition to whatever I said, right, that we are using it for HTTP to HTTPS, but there will be many redirect things you need on the load balancers. Like you want to send a custom response for your 503 error. So you can do that. Here is the sample they have provided for how you want to do it. And second is you want to redirect to another external URL. You can do that, or you can forward to a single target group, or you can forward to multiple target groups. So all these things are already available here, and how much you want to do and all those things. Like example, like you can take the path, this one, and then add action and then forward to, so which target group and how much percent, 10% of the traffic, and this target group, and remaining 90% of the traffic for /ABC star, something like that. Okay, so all these things are doable via UI, and now all these things we will be able to do via Kubernetes manifest. Okay, so that's what I'm trying to explain. So now here, if we go back to this one, so this part we have cleared out what is it by seeing at the screen. Okay, means like AWS management console, ALB screens. Okay, now what is this part? So the action name, whatever you provide in the annotation, must match the service name in the ingress rule, and service port must have use annotation compulsorily. So let's go ahead and then see our manifest and then get that understanding little bit, right? So let's go back here, and we will close my readme file here, and then we'll go to 0805 ALB ingress SSL redirect, and this is the one. So now let's see. The first thing is SSL redirect setting. So let's go ahead and then understand that first. So in our manifest, we are supposed to make two changes. One is add the custom action annotation based on whatever we have provided. So I have added ALB ingress, whatever the kubernetes.io actions dot, whatever the name you want to give, you can give the action name here. I gave SSL-redirect, and I provided the JSON file with the standard syntax saying that the type is going to be redirect, and the redirect config is going to be HTTPS protocol, and port is 443, and the status code for that redirect is going to be HTTP_301. The same thing I have provided here. So this is change 1. And change 2 relates to what we have discussed here. Okay, so which is nothing but the action name in the annotation must match the service name. So as we told in port 80 rule, the first rule should be /* for this, correct, right? So path is equal to /*, and the backend with service name and service port. So service name should be always the action name whatever you have given here, which is nothing but SSL redirect, right? And the service port is going to be use annotation, the same thing whatever we have discussed here. So service name is going to be the action name, which is nothing but SSL redirect, and service port is going to be use annotation, the same thing we have defined here. So once we make these two changes from the template whatever we took from 0 to 084, which is 07 ALB ingress SSL, just add these two changes, which is SSL redirect setting, and one more is path related SSL redirect setting. And then once we apply these things, automatically what happens is all the rules present here, right, all these rules will go away, and then whatever the rule we have seen, right, whenever it is /*, then redirect it to http:/host and then :443 port /path $path, and then again query question mark and then query. So like that it is going to auto create all those things. So now we have completed this step related to it. Okay, so now we'll go ahead and then deploy all the manifests in our next lecture. So after implementing this, what is going to happen? So that's another important thing, right? So HTTP to HTTPS, it is going to redirect. So let's see that also. So this is our current architecture, whatever we have seen as part of previous section, which is ingress SSL, and then the context path based routing and all those things. So now what happens whenever you implement this SSL redirect is, so SSL redirect related changes we will be updating in our ingress. Those are two changes whatever we just now discussed. And then what happens is whenever you access any HTTP URL, automatically browser will redirect to HTTPS URLs. Okay, so that's what is going to happen now. So let's go ahead and then deploy and then test it now. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So let's go ahead and then deploy all the manifests and then test it. As of now, if we access the SSL demo, right, http:// and then SSL demo.kubernetes kubeoncloud.com, and if I say /app1/index.html, it's let me take this as HTTP URL and then test it. Okay, so let me close it and take the new private window, right? And I'm going to access HTTP and then test it. So once we implement, again we can test this one, right? So, and then it serves the not secure page, which is nothing but whatever we have provided HTTP, it provided the HTTP URL only. And once we implement this change, even though if we provide HTTP, it is going to redirect to HTTPS. So let me close this and go back to our browser and then implement this. Okay, so let's go back to terminal and then go to 08 ELB application load balancers, and inside that we are going to go to 0805, which is ALB ingress SSL redirect. Okay, and kubectl apply -kube manifest. Okay, so what happens here is already other things are created, pod, deployment, all those things. So those will not be, those will be in unchanged state. Only the ingress user management REST app service will be configured with whatever the additional changes we have applied here. Okay, so the additional two changes, which is SSL redirect setting and then SSL redirect path, right? So now let's go to our EC2 management console and refresh our load balancer, right? And let's go ahead and then edit the HTTP 80 rule. Earlier you have seen all other rules, so now you see automatically this has been changed. So earlier you have seen app1, app2 and then / for user management, but now the rule has been changed, stating that path /* then go to https host :443/ again #path and then question mark and then query and then status code is HTTP 301. So this change, whatever we applied, it took place. Okay, so now we are going to say file new private window, and then I'm going to say http:// demo kubeoncloud.com, right? And so I'm going to say app1/index.html. So it should redirect to HTTPS. You can see that, right? So now I can close this again and then I can open a new private window and I can say http:// /kubeoncloud.com/user mgmt health status. Okay, so now if I click on enter, it should redirect to HTTPS, right? It redirected. You can see the secure symbol here, right? So you can even see the certificate here. Okay, so that's about it. So whatever we implemented, it has been taken place and then working as expected. Okay, so let me close this browser and then come back to our steps, and we have implemented and then tested everything. So the next thing is, if we want to, means like this step you can remove. So I added unnecessarily. Okay, so I'll remove it. Okay, so now you have accessed the application and then tested it, and then now finally you can clean it up. Okay, so now you can clean it up whatever we have implemented. Okay, and then kube manifest. Okay, so I have completed the cleaning of the manifest. So if you go here and then refresh, no load balancer is available. One thing we need to do is we need to manually remove our SSL demo kubeoncloud record set. Okay, so this also charges money. So ideally, if it is minor cents only, but why we need to have it here? Okay, so our demo related to SSL is completed. I will delete this. Okay, so this is gone. The next thing here is cleanup is done. One important thing you need to know about annotation reference is about the location where this annotation can be put. Okay, so this is additional tip. So we'll open this in a browser, right? And if you see this annotation table, right? So this annotation can be created only in the ingress manifest. Means like this annotation you need to only update in ingress manifest. You can see other annotations. They can be provided both in ingress service, either in ingress or either in service in the sense whatever the node port service we are creating, there you can add it. So the best example for it is our health check URL, right? So ALB ingress Kubernetes IO health check path, right? So this will be provided, means like it can be used either in ingress manifest or in the service manifest, which is nothing but our node port service. So like that, the location of annotations will be provided here where you need to add it. Accordingly, we need to be careful about where we are adding. So if we have a service level scope for that, then if you need it in service level for specific applications, you have 10 applications and then you want the auth session cookie to be only from one specific application. So you can apply that only in that respective service level. So like that, the greatest advantage also we have with these annotations related to application load balancer in our ingress manifest. Okay. So this completes our SSL redirect section, and in our next lecture we are going to work on ALB ingress external DNS. Okay, so far you went to Route 53 and then adding the things manually here, right? So but once we implement the external DNS concepts, so once you deploy all the manifests, then automatically your Route 53 record sets also get created automatically. So in our next section we are going to deal with that. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture we are going to understand about ingress and then external DNS. So what is this external DNS and then how we are going to use it? So if we see our current architecture diagram, whatever we have discussed so far, so if you see, other than RDS databases and then Route 53 entries, remaining everything we have provisioned using Kubernetes manifest. So which means like whatever the deployment or node port services or application load balancers and then path-based routing, SSL and then SSL redirect. So we just created the certificate or Route 53 related register domains and then hosted zones with the record sets. These things we have done manually. So but certificate is a one-time job, that is fine. And RDS, yes, means like if we have something from Kubernetes, if we can create automatically RDS databases, that is great. Okay, but this type of explorations are currently in the initial phases. So there is something called K operator. So what it does is, from Kubernetes itself you will be able to create the DynamoDB. Okay, so they are enhancing that, and then maybe in future many of the AWS services will be able to get created using Kubernetes manifest with K operator. But as on today we need to go for RDS databases manually. But for Route 53 entries we have something called external DNS. Using that from Kubernetes manifest, using Kubernetes manifest, and then in ingress adding the annotations related to external DNS will allow us to automatically add record sets or DNS entries in the Route 53. So using this external DNS related annotations updated in the ingress, in addition to deploying the external DNS related deployment in our existing EKS cluster, which will allow us to update the Route 53 entries. So let's go back to our GitHub repo once and then see what we are going to do. So we are going inside 0806 ALB ingress external DNS. So this is divided into primarily two parts. One is deploying the external DNS on EKS, which is nothing but it is a simple deployment with a single pod related to external DNS, and after that applying our external DNS related annotations for our application and then testing it will be the next step. Okay, so now let's go into the 080601, and then if you see here, as usual, if our pod inside the Kubernetes it need to access the external AWS services, it need to follow a process, which is nothing but it need to have a IAM role and then IAM policy. IAM policy outlining which AWS services it needs access to. Example, it needs access to Route 53, right? So IAM policy and IAM role. In addition to that, a service account in Kubernetes which will be associated with this respective external DNS pod. And then all together IAM role and then service account need to be associated so that the external DNS pod will be able to go ahead and then add the entries in Route 53. So related those changes, whatever is required like IAM policy, IAM role, all those things will be our next steps to implement for our external DNS deployment. So I'll see you in the next lecture, and then we'll go ahead and then implement the steps related to external DNS. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to create the IAM policy. So this IAM policy will allow external DNS pod to add, remove DNS entries, which is nothing but record sets in a hosted zone in AWS Route 53 service. Okay. So let's go ahead and then add the IAM policy. So the IAM policy, we are going to put the name as allow external DNS updates. So this is the IAM policy which we are going to add, and its information is nothing but change resource record sets, allow inside hosted zones for all the hosted zones, and also list hosted zones and then list resource record sets. Okay. So now let's go back to our management console and go to IAM, and we will go to policies, and in policies we'll click on create policy and we'll go to JSON tab, remove whatever is there here and copy our entire JSON whatever is present here. Okay, so let me copy this and paste it and go to Visual Editor. So it will validate everything. So these are the actions we have provided in Route 53. One action related to change resource record sets and one more here, two more here. So Route 53 in actions, it is saying that list hosted zones and then list resource record sets. So one is a write and then two are list related. Okay. So I'll click on review policy and provide the name for the same. So which is nothing but allow external DNS updates. Okay. And the next is allow access to Route 53 resources for external DNS pod. Okay. So this is the description. So I'll create the policy, and we need to make a note of the ARN. Okay. So I'll say allow external DNS updates, and then I'll leave this screen like this so that we can leverage this policy ARN whenever it is required. Okay. So now the next thing is to create IAM role K8 service account, Kubernetes service account, and associate IAM policy to them. Okay. So as part of this step, what we are going to do is we are going to create a service account IAM role, and then service account in Kubernetes, and then IAM role in AWS IAM, and then associate the allow external DNS updates policy whatever we created to the IAM role. Okay. So this is going to be the command which we are going to execute for the same. So I'll copy this and I'll go to my Visual Studio Code. I'll say file, new file here, and so the Kubernetes service account name is going to be external-DNS. Inside the cluster EKS demo1 in namespace default. Okay. And policy ARN means like what is the IAM policy I am going to associate here. Let's get that now. Okay. So this is the one we are going to associate. So let me remove this and add whatever we want. Okay. Created. Okay. So let's go ahead and then create it now. So let me come back to our terminal and let me paste it. So once this is created, we are going to perform the verification steps. Okay. So the first thing is whether external DNS account got created. kubectl get sa external-DNS. Okay. So it is going to create a CloudFormation stack. So which will eventually create the IAM role, whatever it is required. So we are going to verify those things also. So let the CloudFormation stack get created. So now this got created. So let me say clear and then kubectl get service account, which is nothing but SA, and whose name is external-DNS. Okay. So ideally it should get created now. So if we want, we can even say kubectl describe describe service account SA and whose name is external-DNS, right? And if you see in its annotations, you can find the annotation related to our IAM role, whatever it has created automatically. So this is the role it has created automatically, EKS-CTL, EKS demo1. This is the role. So now the next step is to go ahead and then verify our CloudFormation stack, right? So I'll go here to CloudFormation, and mostly the new CloudFormation stack created just now, right around 9:31. So I'll click on that, and if I go inside the resources here, right? So you can see the role whatever it got created. So it started with 1QH and then 50 at the end. Okay, so you can see it here, 1QH and then 50. So the same role is annotated for the Kubernetes service account. So I can click on this and then get the role information here. So in the permissions tabs, you can see that whatever the allow external DNS updates related policy we have created, it got associated with this role. So now the next thing is we have verified everything, CloudFormation stack, and then we have verified IAM role and then IAM policy. So let's make a note of this IAM role here. So which is nothing but role ARN. Why? Because in our next step, we are going to use that to update the external DNS deployment manifest. Okay, so I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In the previous step, we have completed the IAM role, IAM policy, and then Kubernetes service account. So now what we are going to do is we are going to update the external DNS Kubernetes manifest. So the original manifest you can find in this respective link, and you can always copy it and then use it as if how you want to need it. Okay, so this is the manifest related to external DNS. Okay, so I have commented it and then used it as per our needs. So let's go ahead and then see that now. So we are going to make 3 changes to the original file. So let me go back to our 080601 deploy external DNS on EKS. So you will have a kube manifest folder, and inside that you will have 01 deploy external DNS, right? So this, if you see this entire manifest, let's have a high level look on what is this manifest. Okay, so it says that create a service account with external DNS, and then also its equivalent means like for this service account what all cluster role permissions it need to have. Okay, RBAC role permissions in Kubernetes. Okay, so it will have permissions to services, endpoints, and then pods with the get, watch, and then list, those permissions. And it will also have ingress related get, watch, and then list. And like this, now we are going to bind this respective cluster role external DNS and then service account external DNS using cluster role binding. So you can see it here. So cluster role is external DNS role reference, and then subject is service account external DNS. So we binded using cluster role binding. So this is a pretty straightforward manifest related to deploy external DNS. And so the RBAC related stuff is completed. Our standard deployment stuff comes into the picture. So deployment template will have a strategy primarily. So default is rolling update strategy, and in exclusive cases we are going to use recreate. Okay, so that is the thing. So delete that pod and then recreate that pod. Okay, so that is the story in exclusive cases. Okay, so now we are using the strategy recreate, and selector is going to be match labels external DNS, which is same as whatever the pod related metadata information. Okay, so now selector is over. The next thing is template, which is nothing but the pod template, and inside that you will have metadata, labels, and then label name of our respective pod. Okay, so in template, 2 things, metadata and spec we will have, and in spec we will have our existing means like our pod related manifest, right? So first thing is service account. This pod will have a service account named external DNS. So its authorization is restricted inside Kubernetes and external to Kubernetes to AWS services based on permissions whatever we have provided for this external DNS service account. Okay, and containers, it said that name of the container is external DNS, and the image it is taking from some of the external site. Okay, which is registry.opensource.zalan.do tpod and then external DNS latest. Okay, and these are the arguments we are going to provide to this external DNS container, right? So what are those? So primarily we need to focus on 2 things which we have commented. Okay, so the source says service and then source says ingress, right? So now what we are trying to tell here is we have commented 2 things here. What are those? Okay, so one is domain filter. Okay, external DNS.myarg.com. Okay, so we'll make external DNS see only on the hosted zones matching this value. Okay, so we commented this out because I really don't want to specifically allow external DNS, means like I can just say kubeoncloud.com here so that it will only match to the entries related to kubeoncloud.com. Okay, but I am leaving it open so that whatever we want we can modify in our entire space, right? So that is one thing. One is domain filter, and second is policy. So upsert only. So if you enable this option, it would prevent external DNS from deleting any records. So usually whenever we are testing it or whenever we are doing it, right? So what happens is, like in production, you can enable this feature so that no DNS entries once created will get deleted. But for us, whenever we are deploying, testing, and then again removing the manifest, obviously those entries need to be deleted, right? So for that purpose, I commented this option. So this, if you enable it, it would prevent us from external DNS deleting any records. So in the record sets of Route 53, so it will allow us to not to delete anything whatever it has created. Okay, so we can go back here to Route 53, right? And any entries created inside that respective hosted zone as part of this external DNS also, it will not allow us to delete them. So if you go inside, so if it creates anything here, those things will not get deleted if you enable this option. So I really don't need it. So these two things we have commented. And one change what we need to do additionally is finally this one. Okay, so already a service account is created. Ideally in this template, this is not required in general. Okay, but whatever they say, whatever they have provided a standard template, why we want to change it to different ways, right? So that's the reason we really don't need to change it. So what happens is, for external DNS service account, we already seen that it is annotated with the role whatever it is provided, right? IAM role, AWS IAM role. Okay, the same thing you need to provide it here one more time. That's all. Okay, so let's go back to here and go back to our cloud formation, right? So this is the one, right? Role. Already we have put this open. Okay, so this is the one which has the allow external update. So I'm going to copy this ARN and then paste it here. So only one change primarily you need to do for this template directly if you use from this course. But if you directly download from the URL, so then this one, and for this demo things to work, then we'll also ensure that this line 65 and then 67 also get commented. So that's the thing. If you use this template, there is no issue. Those two are already there. Only you need to update your role from your account, right? This information. So that's about it. So now let's go back to our browser, right? And we have completed this IAM role update successfully. And we have ensured that 55 and 56 comment these lines. Okay, so why we need to comment these lines? This also we need to discuss. Okay, so if you are using KIAM or Kube2IAM to create your IAM roles, so then uncomment these things. Okay, but we created our IAM role, IAM policy, and then service accounts with the EKS CTL. So this thing no need to be enabled. So those will be in the commented state only. Okay. So that's about it. And line 65 and 67, we discussed about these things exclusively. So this is good. So finally, we are going to deploy this and then verify it. Okay. So kubectl apply. So we need to go to those respective folders. So I'm going to say 08, which is ELB application load balancers, and 0806 will be ALB ingress external DNS. Okay. So I'm going to say kubectl apply -f kube manifest, right? So what happened, inside the two folders will be there, 08, 06, 01, which is deploy external DNS on EKS. Okay, so now inside this kubectl apply -f kube manifest. So let this get created. That's fine. Okay, so now once this is created, we are going to verify the logs. Okay, so before that, if you want, we can say kubectl get ports. It is going to get created in the default namespace only. It is running. So we can even verify the logs with the logs command, right? So all records are already up to date. There is no other errors related to access permissions. Okay, access denied or access forbidden, nothing related to that as far as possible. Okay, so we'll see later what happens. Okay, for now it is no issues. Okay, so I'll close this, and this completes our external DNS related deployment. In our next lecture, we will apply this to our application. So one thing important here is these reference links. Okay, 2 reference links I have provided. So if you need additional information about this external DNS, so you can use this information. Okay, so AWS directly publishes this respective, means like external DNS they are supporting, but currently in alpha stage, but they are supporting in their documentation too. Okay, so I am closing this, and in our next lecture we'll focus on applying it. Okay, I'll see you in the next lecture. Until then, bye bye. Thank you.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a Starfreelancer.